I am VP of Engineering at Cypress. I was with the company for more than 3 years now. I used Cypress for a year before that, so I'm really excited about the test run and what it can do, and the fact that it's open source, which is quite unusual to find this combination of factors. During this presentation, I will just talk about particular thing that you can test, which is how to test React components. And I will take a look at that, not all the variety of things you can test, but how can you test components visually, right? Like analyzing not what they do, the clicks and so on, but how does it all look to the user. So I'll do my presentation here. And to answer questions, right, Zoom is not that convenient for Q&A, as we found out. It's not that convenient for interacting with the audience. It becomes kind of like messy. So what I suggest we do is that we try to use Slido.com, which is this company from Europe that I use at many conferences before. I created an event there. So if you go to Slido.com and you enter SciReact, so which is like what I will try to do, so I'm online and enter SciReact, then you'll be able to find this event, right? And you'll be able to ask questions that I will answer later on, and you can upvote other people's questions. And I'll be able to do like this little pop-up quizzes, right? So for example, I'm in Boston, so I just enter Boston, and what cloud will kind of grow as people join their areas. And we were just wondering where people are joining from, because online Meetup is quite nice. There are no geographical restrictions, unless the time zones. I see a lot of Iowa, great. I see West Coast, I guess, good afternoon. I think I'm the only one from Boston. Yeah. Well, at Slido, you can switch to Q&A and then like ask any question about Cypress, testing, React, visual testing. And as I said, upvote. If you want to say in chat during the presentation, great. Chat in the Zoom. I'll keep one eye on the chat in Zoom. So if I see an immediate question or like comment, I will try to address it. So I think I see 20 people or 21 people voting. So that means people know how this goes. So just in case, I will post this again, Slido.com, SciReact. Great. So let's get started. Right before we start, I will start like I usually start with a reminder that our planet right now is in immediate danger, and it's actually a self-reinforcing feedback loop. So we pump more fossil fuels, they warm up, so the methane starts leaking from Arctic Circle, more trees are burning. So if we kind of get within 3 degrees, which is like 7 degrees Fahrenheit, pretty much all the crops will fail from the heat, the seas will rise, destroying all the cities on the coast and all the infrastructure. And we are already at 1.5 degrees Celsius. So it's not good. And I think it's possible to change this, but we have to act, right? Whatever I say during this presentation about React and testing, you might find it useful, you might not find it useful. But acting on climate for sure pays off. And if you don't act, then for sure it will become actually much, much worse. So I changed my life, less travel, less meat, more biking, green electricity for my house, but also you cannot do it by yourself. So I'm a member of previous organizations. Just join an organization, doesn't matter which one out of this, and start acting locally, at the state level, at federal level. And there are some successes. I don't say we passed Green New Deal, but there are laws that we're pushing at the state level, at the local town level, that actually make a difference. Okay, so this is the end of a climate kind of sad part. So a couple words about me. I had a long journey I've been doing computer vision and image processing for a while. That's my education. Then I kind of moved away from C, C++ to through like C Sharp and Java into CoffeeScript, JavaScript, started doing data visualization on the web. And that's how I somehow ended up working with like web code and testing it as well. So you can find a lot of my projects, like Matt said. If you need NPM package, I probably have written a version of a package somewhere, and it's all on GitHub. I blog a lot, so this content of this particular presentation is also a blog post that you can find on my blog. And these slides are already public, so they're on slides.com/Bahmutov. Just maybe if you want to look at them later on, they're available. Most important question, why did we require Zoom registration, right? Because we're not a marketing company, but what we do really, really well is we try to provide clothing to everyone in the world who needs it. And we do it by sending Cypress t-shirts, just like this one, right? So if you want to receive a Cypress t-shirt for free, just take a survey that we'll send at the end of this webinar afterwards. There are a couple of questions that allow us to kind of judge what people need in testing and how a webinar went and what people would like to see in the future. Take the survey, receive a t-shirt. That's a pretty good deal, I would say. Okay. Nicholas, if you want to ask a question, you want to post it in the chat so we don't like interrupt with like microphone and everything. So I think that would be the best. And you can also ask questions at Slido as well. So for tonight's presentation, I wanted to show how I play Sudoku. So there is this Sudoku that I clone. It's not my implementation, but I really like this game. The way it plays, how stylish it is. I thought it's a great application. And it's a very modern application implemented using React framework. As you can see, you select, let's say, a cell, you pick a number, you enter a number, and it shows you the timer, there are a couple modes. It's pretty slick application. Not only it's like look great on a desktop, if you change the resolution of your screen, then it shows how responsive it is. It changes the layout. It changes how the widgets are drawn. So I think it's actually a pretty slick app, right? And so let's think about, if we work on this app, we probably need some tests, right? And we'll talk about component tests later. But in this presentation, I want to go beyond just testing, oh, I can play Sudoku. I want to make sure that the app that looks very, very well is not broken. It never has weird layout issues when I change one component and styles and accidentally change some other component that I didn't even thought would change, right? So I will show how to test that using visual snapshots or visual diffing. And for that, you need the same data. So I'll talk about how I control the data that each component uses to render itself. And then I'll talk at the end about my actual workflow and the difficulties visual testing presents once you move past, like, I just need to compare images. Like, what do I do when I work day-to-day with image diffing? Okay, so before I do that, let me quickly switch to this screen and ask you a question, right? So the topic for this webinar is visually testing React components. But I'm wondering how much people know about React itself, right? Because I don't want to skip over something and then people will like, huh? What was that again? So I just want to see how familiar people are with React itself, right? So a few people never used it. It's okay. I will try not to use the jargon. Some people use it, half people are using it a lot. No one from Facebook team is here, so I guess 0 for those guys and girls. Excellent. So we have pretty much everyone aware of React and how it works, and a few people who have never used it. I'll try my best not to scare you away and do my best explaining what's going on. So a modern application, which is React application, is built out of components. That's the building blocks of the app. And the way it looks is this. Imagine you implementing a Sudoku game. If you even just look at the game itself, you probably can see particular areas or components, right? So in this game, we have a header. That's where the Sudoku title is, and the new button, new game button is located. Below that, we have the board with numbers. So that's a component. And in the right column, you see there is like a difficulty toggle. There is a timer. Each one, again, is a component. There are numbers, and there are a couple of like buttons and modes, right? So that's another component for like statuses and actions. So those components that you see on the left really match very well with the structure of the application in the source folder. So if you look at a React application, usually you have a source folder. There might be a top-level app or main.js, but the majority of code lives in source components. Again, the name is arbitrary, but people usually name it just components because each one of those things is a component, and you can tell what its purpose is or what it is on a screen just by looking at the name. Footer, game section, difficulty, mode, numbers, timer, right? And if you install React DevTools Chrome extension, then it shows this view where you can just hover over component names and it highlights those components on the page, right, on the live page. So you can actually see where the components live and what they represent on the screen. But I just go by name, and I kind of assume that the board is the board component. So this is how the app is structured. And this is how the top level of the app kicks off. So there is usually an index file that imports React and render method from React DOM. And then it imports the top level component called app. And when it says take that component, it uses JSX syntax, so it puts it in the brackets. And then it renders it into the root element on the page. So on our page, there is a single element with a tag root that will suddenly be filled with live application. So this is how a React application kicks off or starts. After that, it's all components just being responsible for their particular feature on the page. What I just showed is React DevTools Chrome extension. So React team has this extension that you can install, and then you will see everything on the page. Similar extensions exist for Vue framework, for Svelte, for Angular. Every framework has an extension that kind of shows how a thing is implemented. Okay, so we have index file that kicks everything off. It mounts the app component, and the app component, again, it's just a wrapper right now, right? It implements, or it grabs the game component, it imports CSS, that CSS is applied to the game, and then it creates the game component, but it wraps us with a provider component. And we'll see what provider components, but in a nutshell, they store the data. And then that data can be accessed from each individual component. So you don't have to pass all the data for each level from the root all the way to each component that actually needs it. So the app just surrounds the game component with that Sudoku provider data holder. A game is actually most complicated component. So the game is responsible for the board, for like the things on the right, the status, for keeping track of the time. So that's why its import section is actually the longest one, right? It imports each big component like header, the game section, the like status, footer, and then it's responsible pretty much for the whole board rendering. And this is what it renders, right? So it imported all those components, and then it returns this big tree of components, which are its children. Nothing really different, But the interesting thing here is when it puts those children components, right? Like game section, status section. Notice that it actually passes all handlers. So what happens when a user clicks on the status section? So the game is a top level controller that says every time someone clicks on you, you just tell me. You call the callback that I gave to you, and I will worry about changing the data, and then React will re-render the rest of the things. So it's interesting, but in this kind of approach, we'll see it later. The data is stored in a provider, so every component can access, but every time there is a user event, like a click, it gets sent to the game component to be processed. Okay, so once we speak about what each component expects and how it communicates back to its parent, we have to talk about the inputs, where the component is getting its data and inputs from. So here's a component that I show in the bottom right corner called numbers. Its purpose is, or reason for being, is just to render numbers 1 through 9 that the user can select to enter into a cell. It has a little bit of extra logic. A user can select a number and then enter that number in multiple places, right? Kind of like Sudoku can do. So not only has to render numbers in this grid, but also it has to know if a number or render a selected number differently. In this case, it shows it in blue. So you can see the like this is the whole component source code. Let me see if I can go step by step. So in highlighted section, this numbers component is instantiated, or its parent is status section. So status section is the whole right column, and it says, okay, I'll create numbers component, and I will pass on click number handler, so that when numbers processes click event, it will just send it back. So in numbers, we have to know which number is selected so we can render it differently. So we will get the selected number from the context, from the provider that the app component actually created for us. So once we got this number selected flag or status, then we'll just render that particular number differently. So we'll give it a different class. And then by the CSS, it will be shown differently. What about clicks? So the number component receives properties. In this case, the property will be onClick number. So its parent says, anytime someone clicks on number, you just call this prop onClick number. So that's why this component onClick just executes whatever is passed to it and passes the number. So really, this component only has two inputs. One comes from the provider, that's the data, right? Number selected. And another one is the way to send events back out. So I kind of think of this as this little flow diagram. Our numbers component receives properties, receives context, and it also receives user clicks. User click is nothing but another input, all right? So it's kind of weird to think, oh, well, the component is set up and it has a prop, but it also receives user input, right? But if you think about your component as the smallest piece of your application, it will receive a properties, it will get some data from a provider, and also it has to receive the clicks. And what does it output? Well, it has to render itself, so it will output this piece of JSX with DOM, right? But also it will send back those prop calls, right, on click number. That's also output, right? That's how the component communicates with the outside world. So my view of a component as being the smallest piece of application code that takes inputs and produces outputs. Like I thought about this for a long time. To me, it's almost like unit testing. In a unit test, you have a function or a class and you send some arguments and then you receive a result. In component testing, you look at component, you think about everything that it receives and what it communicates back. So in this case, it receives props, context, user clicks, and it produces different DOM, and it also produces calls to the outside world to prove a property. So it's nothing but a small unit of code. So let's see how we can test a component, right, like this one. So because I work at Cypress, I love working on open source testing tools. The Cypress is open source MIT license test runner. You can install it by just adding it as a dependency. But I also have written this extra thing. Usually Cypress is meant for end-to-end testing. So it can test any website. It doesn't care about the framework. It just looks at the DOM. It looks at the network, at cookies. Doesn't matter how it's implemented. But now we want to test a React component and do something specific about it. So for that, I have written a React-specific adapter. And I published it under the name Cypress React Unit Test. It's also MIT licensed open source thing. So in our case, we'll install Cypress and Cypress React Unit Test. And to be able to use Cypress React Unit Test, you have to add Cypress React Unit Test to Cypress support file and the plugins file. And those two things are kind of mechanics of Cypress, because Cypress tests run in a browser, but they also have to communicate with outside world. So by using these things, you will tell Cypress, hey, use my application bundling, for example, settings from React scripts, so that when my spec code is processed, it's processed exactly the same way as my normal application would. Okay, so this is the installation part, and then you just have to say experimental component testing flag true. Right now, we're still experimenting with it. It's not going anywhere, but you have to enable it specifically. And then say, those component tests will live in the source folder. I like my tests to live right next to my code. We in Cypress, by default, keep end-to-end tests separately from the source folder. They live in usually Cypress integration folder. But for this example, I want my specs to be right next to the component. So that's why I'm saying component folder where those tests are. Cypress will look that is inside source. Okay, so that was installation. And this is our first component test. This is like why we are here. So let me go through this. This is the whole spec file. Let me go through it one by one. So one thing we have to do, we have to import a couple of things. We'll import the mount function from Cypress React Unit Test. Think of this as render from like Enzyme, right? This is a function that will take the component that we import in line 3, and then we'll just say mount. And because mount takes JSX as well, you can pass additional props here. But right now, we just want to say like bare minimum component numbers, just mount that. This is an asynchronous command. And what it does, it takes our component, and inside the browser, what we will see in a second, it actually mounts it and scaffolds as that component as a full web application. It literally starts React rendering in a special iframe, all right? So after that, it becomes a menu application that just runs by itself like a full-fledged end-to-end web app. And after that, we can use all Cypress APIs and all Cypress commands to interact with the application, for example, to check if every number is present inside the DOM. So if numbers actually renders, all right? And Rito, I agree. Why does it have to be full-fledged web application? You will see in a second. Because when I work with components, I want to see what's going on. So the shallow render will only render the top level, will never render the children components, right? It's fast, but I don't care about that. I kind of trust React that if, let's say, if it can bundle, if there are no undefined variables, that it actually will render. But what I really want to see, like, if I just mount that numbers component, what does it do on the screen? What does it do in my browser? And this is the Cypress test runner for that particular test. So on the right, you see the numbers 1 through 9. This is the number components actually rendering into the DOM. On the left, you see the Cypress, what we call command log. So it shows the name of a suite numbers. It shows the name of a test, shows all numbers. It shows the mount command inside the test. So it mounts it. And then it shows that it ran contains command. And contains command is looking, in this case, for an element with selector class status number and text1. So it literally went and checked that each number is present in the DOM with expected class name. Now, but this is where things kind of don't look good, right? I want to see the full application. I want to see what my component is doing for real, but it's not real, right? In a game, the numbers component doesn't look like that. It looks like a little grid. So what's wrong? Well, we didn't apply any styles. Our component, when it renders, right, it has certain class names. So if I want to see those classes applied, I have to, in my spec, to load them or import them. And because Cypress component testing applies the same bundling, the same Webpack settings, I can do everything I wanted, or from my test, I can do everything I can do from my application code. So in this case, I'll just say import app CSS, just like my app component, as I showed. And what happens in the same test, all of a sudden you will see this. Because now there are styles, right? So now I can see not exactly the same picture, but pretty close to what's supposed to happen. So why don't I see exactly the same little grid of 3x3 numbers? Well, my numbers component has CSS in app CSS that actually assumes certain structure, right? It probably assumes there is like a section with a game and then something else. So if I want to mount my component the same way, I have to mount this. I have to look at my application structure and say, my numbers component, but the CSS assumes that it's inside a section with a class status and inside the class name intercontainer. So really, it's kind of the opposite of shallow mounting, right? Or shallow rendering. In shallow rendering, you skip all the children. In this case, I skip all the parents. I just need their class names and the structure. And then my CSS will actually work correctly. And the numbers component now inside this iframe on the right looks exactly like it looks in real full application, okay? So this is nice, right? So what about what component does? What happens when a user clicks on it? So again, to me, a click is almost like input. And in this case, when I'm mounting my components, I will pass it a prop, just like this component should be used, all right? So instead of real function, I will create a size stub. So Cypress comes with Synon stubs and spies and clock control, already included. So in this case, I'll say numbers, on-click number, and I'll just say size stub, and I'll give it an alias so I can find it later. And then, sorry. So look at this. I apologize because my animation is wrong. I will find number 9, and then I'll click on it. Okay, so this should trigger that stub that I just passed for the prop. So that's my assertion right here. Find that alias that I gave, click, and make an assertion. Should have been called with argument 9. Okay, so this is how it looks. Again, you see on the right the iframe with that numbers component mounted. On the left, you see more commands because now Cypress says, okay, you mounted unknown, you found using contains number 9, and you clicked. And then it shows that my stub was actually called, all right? And you even see like the click, the alias. So I know that I found the right stub. And then in number 4 command, I got that click by alias. And in green, the assertion is passing. Really, my component, when the user clicks on a number, calls the prop supplied with the right argument. Okay, and it calls it just once. Okay, so this is how we can check if a component is communicating back with the outside world. Okay, what about the second type of input that my component expects? It expects some data, but it reads off context provider. Again, I can grab that context from my application code, and I can surround the component when I'm mounting with a fake provider, because my component doesn't care where the provider is coming from. As long as it's the parent, it will just read off it. So in this case, I'm surrounding and I'm saying number selected is 4. Then I'm mounting the component. Again, so my animations are all wrong here. And then I check that the number 4 number actually has a class that expected. Okay, so I'm rendering my component surrounded by the data that I can control, and when I check that the DOM has expected classes. Okay, now this is a functional check, right? And it passes. So I know that if my context provider has number selected equals to 4, that DOM element will have a class. But I cannot actually confirm that it renders it in blue. I can't really assert that maybe it's a certain size or spacing, right? I only did a functional assertion. I only asserted that my component functions, it actually adds a class name for selected number, but we don't know what it means, right? And how it looks. Okay, so for that, we're moving away from functional testing into visual testing. And the question what visual testing needs to answer is, if I change the CSS in my application, or maybe SVG, or the structure of my app, will it still look right? Or will it be broken? And turns out this question is very hard to answer, right? Because I, as a user, can look at the page, and if I know how Sudoku used to look and how it's placed, I can say, yeah, it looks good. Yeah, it does look right. Like, you did not break it. You did not put elements out of order or like screwed up the styles. But the computers cannot. They don't have no concept of something looking right. Okay, so what do we want to confirm? We want to confirm that when the component like number has nothing selected, when it looks like on the left, this grid on the left, or when we actually have a number selected, then it actually looks like something on the right. But we want to confirm the look of many components, right? For example, we want to confirm that the status component looks like this, but if I selected different modes, then it actually has those toggles all the way to the right and those things in blue, like nice stylish components. Even worse, I want to be able to change CSS and the structure and maybe bump the libraries of React and React DOM and any kind of dependencies. But I want to still confirm that my app, that not me, but someone else spends so much time making stylish and look nice and adjust the colors, still looks good on desktop, still looks good on a tablet, and still looks good on mobile, right? So I can easily say, yeah, just take a look at your app when you modify something. If it still is blue and looks like, then it's okay. But when you think about the permutations of resolutions, components, different inputs, right, different user flows, it becomes a huge problem to keep checking it and rechecking it manually at the end of each sprint or week or before each deploy. So what can we do? So it turns out, does it look right is very hard to do, right? Because it requires actual user input and it takes a long time. That's why there's like this old kind of clock, and computers cannot do that. But what computers can do very, wait, before I do that, time for a pop-up quiz. So the pop-up quiz is, have you used visual testing tools, right? Before I start explaining what visual tools are, I want to know if you use them so I don't have to go through the details. Or I forgot to add an option to ask if you're working for Applitools or Percy or Hopper or one of the commercial providers. Like, okay, excellent, excellent. So if you never use visual testing, this presentation will be super good. If you use commercial providers like Percy, Applitools, Hopper, then It's perfect. And I really love people who use open source tools, because you will probably agree with the pain points that I will describe. Excellent. Thank you for quick. Paul, perfect. Okay, so the computers cannot say, does it look right? What computers are really, really good at is to say, do these images, two images, look the same, right? So they're super fast, they're super accurate. Humans are absolutely terrible at comparing two images and comparing and saying, do they look the same, right? That's why for kids, they love with like find 10 different things in those two pictures. Kids love it because it's so difficult, so it's fun. So what does it mean? Does it look the same in this context? So for this presentation, I will install Cypress Image Snapshot, which is open source image comparison tool adapted for Cypress. Just like before, I will have to add one line to my support file, one line to my plugins file, and that's it. In my test, right after I confirm that my numbers component is showing number 4 with particular class, that means the DOM has been updated, I can add one more command now. I can get the whole component, right? And then I can just use a command called match image snapshot. So that comes from Cypress Image Snapshot. It's not part of Cypress, it's what the plugin provides. And I can give it a name like numbers selected. Okay, so here's where the things are very similar to the way just snapshots work. So the first time you run this test, that plugin will take a screenshot of that numbers component. So this site get, it limits like which component you want. So not the whole screen, but just that component, that numbers component. So the first time it takes the snapshot and it doesn't find a snapshot with the same name. So it doesn't find like numbers selected PNG. It will just save that image on disk as an image file. And then it will just pass. Okay. So this is what you will see. In your repository, you will see number selected snap in this case. So it adds a little suffix image, right? So you can look at that. And if you're happy, if you think, yeah, this is what I like expect my numbers component to look, right? Then you commit that file to your source repository, okay? And you keep it with your code, right? So one of the things, if you want to do it yourself using open source tools, the more commands you use match image snapshot, the more images it will create and the more images you have to store, right? So it's exactly the same approach as jest, where you store the snapshot object. For storybooks, it's a little bit different. I don't know if you store the images yourself or if you use Chromatic, which is their image snapshot thing. I think it's the Surface where you don't store it. Okay, but we are doing everything ourselves. So we store them here and we write more component tests, right? Everything is a component. So we take all those snapshots. So now my repository has a big folder with all those components. I take different components. I take them in different input values, right? I take empty field. I take solved game, all of it. Okay. So now here's the main thing. So let's say someone comes in and they accidentally or on purpose modify the CSS, right? In this case, they replace padding with slightly different number. So how does this affect our component? Just by looking at CSS, we can kind of guess, but we're not sure. Maybe it does nothing. Maybe this status number padding is never used, or maybe it's overridden by somewhere, right? But what happens when you run a visual test? Now to match snapshot, we'll save a snapshot and it will find the previously saved snapshot and it will compare. So the thing that we saved before, the thing that we saved and added to our repository is called baseline image, right? It will be just there. We are happy with it. We reviewed it manually when we committed it. So we are happy. We think our application, our numbers component should always look like that. That's it. No changes. That's good. And the new image, the one that we just took after modifying CSS, well, it looks like that. And here's the thing, right? If you just kind of cover your screen, right, with your like hand, and you compare, you're like, yeah, it looks the same. Again, people, humans, are really bad at looking at the image and saying, does it look the same pixel by pixel or different? But computers are really good at taking those two images and comparing pixel by pixel by pixel by pixel, color by color, right? And in the middle, you see the difference. So in red, Cypress image snapshot highlights for you all the pixels that are completely different between left and right, between baseline and the new image, right? And so the test will fail because that command will fail. And you look at this image that's produced, and now you have a choice, right? Is this the change that you expected? Or was it a wrong change, right? So if it's what you expected, then you just override your baseline image with a new image and you commit it. And now it becomes the new baseline. If you don't think it's appropriate, you roll back CSS and it again will generate normal images. Here's another diff image. So let's say you have baseline image with just a game, and for some reason, you generate the new image, but the board is different. So where are the changes? Well, look at the middle where pixel by pixel highlighted all the numbers that are different, all the selected cells that are different, but everything on the status column was the same. So that's why there are no highlights anywhere else. It's just the board that has changed. But again, this image diffing, as it's called, is really good at finding all the changes and breaking the test because the assertion is broken. Okay, so the first time it runs, save a baseline image, commit it to your repository, and every time you run test after that, if there is even like a couple pixel or 1 pixel difference, the test will break because the new image doesn't match. Unfortunately, sometimes it doesn't match for a wrong reason. For example, if I want to test this clock component, it keeps ticking, right? Every second it's different. So here's my test for the clock. I mount the application. I select just the status time, right? Which will give me just this piece of a screen, right? And I say, well, it should be 0, 0 at the end. I mean, at the start. Okay, yeah. But what if I want to take it after 10 minutes? Or what if a snapshot is taken, but the clock changes and sometimes it's 0, 0, sometimes it's already 0, 1, right? So I get this flaky test or inconsistent test, right? Because the clock keeps ticking. So this is a very common problem. So in Cypress, you can control the clock. It's like right out of the box. So all you have to do before you mount, you say clock, and that freezes the time. Now you can mount your component and you say status time should have text 0, 0, 0, right? So this is your kind of like functional assertion. But then you take a snapshot. And on the right, I'm showing the snapshot. And even better, then you can advance the clock manually. So in this case, I'll advance it by 700 seconds. And then again, I will take a snapshot. I'll give it a different name so they don't compare it to the wrong image. And now this is a snapshot of the timer after 700 seconds. And again, the clock is frozen, so I can take my time, take a screenshot. There will be no changes. So it's very reliable, repeatable component test. But another thing that I showed, right? Every time like you have a game, right? The board changes. And this brings to me the question. So I describe how application is structured. In React, it's by using components. There is a top level component, and then there are more components. So why can't I take the top level component, mount it, and just take a screenshot of the whole thing? Because then I will compare and confirm that the whole game looks the same. So here's the structure of our application, right? We kind of seen it from the source files. We've seen it from the DevTools. Our app has a game has like header, footer, there are timers and numbers. So I've shown how we can test like little pieces, like numbers, timer. What's the difficulty about the app? It's kind of the same, right? Mount it, make sure it looks the same, click on it, make sure it acts, how it should act. But we can't. And we can't because even though it looks simple, and you can definitely mount the app and take a screenshot, but the problem is every time you mount it, every time the new test runs, the board is random. Otherwise, it would be a very boring Sudoku game, right? So this randomness, that's what you've seen in previous screenshots where all those numbers will actually break the image test. So in order for you to write successful component level, or even end-to-end level visual tests, you have to make sure that the data is deterministic, that it's the same, but it doesn't change test to test. You have to take all the randomness out of a test. So in this case, you have to look at how the game initializes the board. So if I look at the game JavaScript file, then I will see that it imports get unique Sudoku from somewhere, calls it, right, and gets back two arrays, one with initial set of numbers, like just sparse, and another set of numbers, which is like fully solved board. Okay, so this is where the game is getting the board numbers. And those numbers, I can look at them in DevTools, I can copy them and save them as JSON files, right? So this is just one example possible board, right? But I copied them, stored it. So now in my component test, I'm doing the following. I'm importing the module that initializes the board, right? That has this get unique Sudoku. That's what the game imports and calls. And I'm stopping it from my test. I'm saying, if someone calls get unique Sudoku, you always return those two arrays that I load from JSON files. That means that when my game runs, it will always get the same set of numbers, right? And then I can mount the app. Again, I control the clock so it doesn't tick. But now I can take the whole container and just say match image snapshot and give it a name. And so this is how it looks, right? So remember, let me just go back for a second. When I copied those arrays, 0 means it's empty cell. So then there's like 9, 2. So when I look at the game, it's 9, 2, like it's the first row with like empty spots. So I know what to expect. But the best thing, I can rerun this test as many times as possible or as I want, and it's always going to be 9 to the same board. Okay. Once I have deterministic game board, I can start playing the game because I know where empty cell is. So for example, I took one screenshot when the game just started, and now I made one move and then confirm that the DOM has updated after the click, and I can take another screenshot. And this is how the game will look after one move where I filled that 6 in the top left corner. Again, by having deterministic board, I can now play a couple of moves, make sure that all the cells are highlighted correctly, things like that. Ritu, here's another thing why I absolutely against shallow rendering, and I think full-fledged component running as an application is so important. So what you see in this video is the test and me interacting with the test while it's running. So I have my VS Code running, and I have my browser, which is like this Cypress is spawning and controls this and runs. So once the test is over, I can hover over each command on the left, and Cypress takes automatic dump snapshots. And then when I hover, it creates it. I can see fully how my app, or in this case, component, looked at each step of a test. So this is how it looked when it was mounted. I see what it's called get unique Sudoku. I see all the cells. I see how I clicked on the first cell and selected 6 and it was highlighted. And when it highlighted all other 6s, I can completely debug this, right? I can understand step by step what's going on and how my component, not even the full app, just my component reacts to everything. Okay, so I covered everything and it seems easy and it is easy. But now we're getting to a few points where where the open source solution is limiting. So let's look at local workflow and CI workflow during pull requests. So if I run Cypress, which I use Cypress open command, and I take the screenshot, you will see like there's some resolution, right? Like let's say in this case, 1300 by 600. So maybe I took like the header. Great, I'm happy, I committed. And then I do the headless mode on CI. And all of a sudden, I see that the screenshot is actually 650 by 300. So half of resolution in each dimension. So what's going on? Well, when you work on a Mac, you actually it takes resolution in double density mode, like density per pixel per inch. So I already hit a problem. The screenshots that I took while I was running the test and the screenshots that CI will take, let's say on Linux, right, are completely different. Right? So there are ways I can kind of do things, but it's not easy. So what I usually do, which is kind of ironic or surprising, when I load that command from Cypress image snapshot, I actually disable it in interactive mode. When I work with tests locally, I only have my functional assertions. Yeah, I still confirm that everything is there, but I don't take the image, right? So what I do instead, well, when I work, I just say, well, I'm skipping the snapshot. What I do instead, right before I push the code, I actually run Cypress run, which is non-interactive headless mode. In that case, it runs and it will be the same as the headless thing. If there are any changes, the test will fail. But if I really want to update the screenshots, I'll set environment variable and it will update all the screenshots. And then I can review all the change image files and say, did I mean this change? If yes, I'll commit it. If not, I'll go back to the test. I'll go back to my source code, right, and do it again. So kind of not very useful, but that's the thing I have to do because Mac has a different resolution. It will not match my CI. But even worse are these little things. If I take a screenshot on Mac, let's say on Chrome, Electron, Firefox, then it will look something like this. It's 0, 0, like it's this little timer component. And then I run the same component test on Linux CI, and again, it's 0, 0, great. Right, so this is what my CI will generate as an image. And guess what? Cypress image snapshot compares those things pixel by pixel, and it will tell me there are differences. And I was like, what is going on? But the difference is because of rendering. The fonts are different, the rendering are different. Your GPU, probably we disable GPU on Linux on CI, but still like it runs on your local machine. So there are tiny pixel rendering and aliasing differences that will manifest and will fail your test, right? Alexandra, if you have to jump off, yes, we're recording this presentation. I'll post it, follow me on Twitter. We'll post it right on all the websites, right? And it's definitely will be there. And if not, find the blog post or find me and it's available. And also we'll do the slides. Okay, so what do we do about it? Well, I want to take the image snapshot using exactly same conditions, same operating system, same browser, everything, locally as I do on CI. So the way I do it is by using Docker. So on CI, I probably will use one of the Docker images with Cypress anyway. I can have a Cypress included Docker image that even has Cypress pre-installed, and I can just run the same thing locally. It will go through the tests, and it will generate things exactly the same way as what I run on CI. So before I push my code, I don't even do Cypress run. I do this Cypress Docker run, which will use Docker locally. So that means all the fonts, all the browsers, everything is the same as CI. And on CI, I will just use an image with exactly the same thing. So Cypress included right here is actually derived from this image with browsers pre-installed. And that's how I guarantee that all the rendering details will be exactly the same. Is it the most convenient thing? No. But it's open source. I don't have to pay anyone. I can just do it. Great. So what I do on CI. So imagine you run things. So you have, let's say you develop branch, and then you open pull request from another branch. You trying to add a feature. So what I do is that I don't want to fail all my Cypress tests on image differences, right? And really, yes, you can add tolerances, but you'll never know if you're adding tolerance to the font rendering or to the actual thing. Maybe you will cut off the corners and not detect like the actual problem. So I'm really not a fan of tolerances, because you cannot say just tolerate the fonts, but not actual thing. So on CI, I will actually set a flag for Cypress image snapshot, don't fail anything. All the tests will pass. What Cypress image snapshot does, it saves diff files with those like baseline, new image, and the difference. So at the end of a run, if there are diff files, I can find them and I post a status on GitHub for that commit saying there are 0, diff files or 5 diff files, and then I know my functional tests all passed, but there I'll say 5 change images. I need to review them and they're stored as test artifacts and see if that's what I meant. And if yes, then I'll actually update the test locally, commit the new images, and then push it. So it looks like this. This is my little status check. It says there's 1 change file. It could be a new file. It could be a change file. I push updated thing, and the visual test is green. So I really suggest strongly that you separate functional status, right? Is there a button? Can the user click? Does the component work as expected? From visual statuses, right? Where you say, yeah, it worked, but the color change, or the font change, or the positions change. Because these are different things, and you probably want to treat them differently and understand where the problem is. Is it coming from logic errors? Is it coming from visual errors, right? Very convenient, especially when you upgrade the libraries or CSS, right? Especially automatically, does it still work and does it look the same? So this is my workflow. Okay, so time for the very last quiz. This is very, very simple, right? All I'm asking, do you want to use this, right? Now that I showed what it can do, right? How easy it is to write one, right? I showed like a few limitations. Do you really want to try it, right? 1 being like, I don't want to try it at all. And 10 being like, I want to do it like today, right? Like right before going to bed. Excellent. So yes, I've done a survey of like features that people find important about component testing, right? And let's talk about snapshots, right? So people use just snapshots where you can store like objects and do the same kind of automatic diffing, right? And storing and diffing. And people are like, I don't really care, because like it's hard to understand if something changes, what has changed, right? Because there's a giant object and something has changed. But for visual testing and this visual diffing, you kind of, as a human, see very well what has changed, right? And instead of saying, if I change the CSS, what does it mean? Instead, you will see an image saying, if you change the CSS, this is what happens. Your header moves here, this thing blows up, and the color of this button changes. It's so obvious, and it communicates very well with other people on a team, right? With your designers, project managers, like even like user group participants. Do you like this or that? do you think we should really go with larger buttons or flat design? Here it is, right? So I do agree with people who voted highly for this kind of testing. I think to me, visual testing really complements, right, the end-to-end testing, functional testing, component level testing. It's a super tool that I do suggest that you keep or try in your arsenal. So I've shown how to do React component testing using my library Cypress React Unit Test. I showed how to use visual snapshotting using open source tool. I showed how to control your data so you get the same image consistently so you can compare it. And I showed like my local NCI workflows. I have to say it's great. Free tools, perfect, love it, easy to try, easy to see. It does take a while to actually use them, right? It's easy to generate an image, but then you have to think, where do I store it? How do I update it? How would I render consistent image on my machine versus CI machine? How do I review those changes? Right? Do I have to pull the branch, update images, push it back? It's a little bit of an effort. That's why third-party services like Applitools, Hub, or Percy. By the way, Percy was just sold like last week or acquired by Browser Stack. So many companies now think that visual testing is pretty important thing in addition to end-to-end testing. So I'm really happy to see Percy acquired. Thank you so much. I put the slides online, they're public. In that repository, right, I actually, as I was working on Sudoku and writing tests, I actually recorded a bunch of little short videos showing like how to test numbers, how to do that and that. So there is like more than an hour of little videos showing what I've just shown, but in detail and explanation. So take a look at the repo, it's all there, absolutely free.